When you plug in your computer to the network, it probably gets an IP address from a Dynamic Host Configuration Protocol Server, or DHCP. DHCP is an automatic way to assign these IP address configuration settings, and we've gotten so accustomed to simply plugging into a network and receiving an IP address automatically that we often don't even think about the process that we're going through. But what if we connect to a network and a DHCP server is not available? In that case, Windows will still assign itself an IP address, although the IP address that's assigned is a bit limited. The address that would be assigned in that case is an APIPA address. That stands for Automatic Private IP Addressing. This is not a static address, and it's not a DHCP address. Instead, this is an address that's assigned when DHCP is not available or a static IP address has not been configured. When I say that this IP address is limited, I'm referring to the fact that it is a link local address. That means the IP address that you've been assigned can only talk to other devices that are on your local network. You're not able to route any traffic outside of your local subnet, therefore you're not able to communicate out to the internet. If you were to look at the IP address configuration you received, and it's an IP address between 169.254.1.0 through 169.254.254.255, then you've been assigned an APIPA address. And there may be times when you're connecting to a network that requires you to configure the IP address configuration yourself. We refer to this as static addressing, and you would add your own IP address, subnet mask, default gateway, and any other IP settings. All of these settings would probably be provided to you from the local network administrator, and it starts with the IP address. This is a unique identifier just for this system, and nobody else on your network has exactly the same IP address. The IP address is also included with a subnet mask. These two go hand in hand, and when you're assigned an IP address, you're also assigned a subnet mask. And the last address configuration to provide you the bare minimum of connectivity outside of your network is the gateway address. This is a router's IP address that allows you to communicate outside of your local subnet. Because we're often communicating to devices on the network by their fully qualified domain name, we need some process that will be able to resolve an IP address from that name. The process that performs that resolution is DNS, or Domain Name Services. This converts your fully qualified domain name to an IP address. It can also take an IP address and tell you what fully qualified domain name is associated with that IP. You normally add two separate DHCP servers in your configuration just in case one of those servers is not available. If you choose the option in Windows to obtain an IP address automatically, that's referring specifically to DHCP, or the Dynamic Host Configuration Protocol. You're effectively telling Windows, automatically fill in these blanks, but if I specify anything manually, use those static parameters. And an IP address that's on every single system you use, and you may not even realize it's configured on your system, is a loopback address. In IP version 4, the loopback address is 127.0.0.1. If you wanted to troubleshoot your system to see if your IP stack is working properly, it's very common to ping your loopback address because that's one IP address that should always be there. The DHCP process is an important one. If you don't have DHCP, then you're not able to automatically assign IP configurations for all of the devices on your network. That's why if you look at the design for a corporate or enterprise network, there will be multiple DHCP servers available on that network. That way, if one DHCP server is temporarily not available, there will be other DHCP servers to provide you with that IP configuration. But if you have a laptop, you might be traveling to many different locations and connecting to many different networks. Some of these networks may have DHCP available, others may not have DHCP. And as we mentioned earlier, if there's no DHCP server, you'll be assigned an APIPA address. However, you may not want to be assigned an APIPA address, especially if you're connecting to a trusted network that just happens to not have an available DHCP server. You might instead want to use a function within Windows called the alternate configuration. With the alternate configuration, you can have another set of IP configuration settings that are used just in case a DHCP server is not available. An easy way to see the IP configuration on your system is to go to the Control panel, Underneath the control panel, choose the option for Network and Sharing Center, and inside of that option, choose the link for Change Adapter Settings. This will bring up a list of all of the network adapters in your system. You can right mouse click on any of them and choose the option for Properties. Inside of this Properties screen, we can look for the IP version 4 configuration, and we can choose the properties for that option. You can see that this is where you would assign automatic DHCP IP addresses or static IP addresses. If a DHCP server is not available, you'll get assigned an APIPA address unless you've configured an alternate configuration. Inside of the Alternate Configuration tab, you can choose to define a static IP address, subnet mask, default gateway, and other important IP address settings. This means you could use your laptop at work during the day and use a DHCP assigned address from a corporate DHCP server. But when you take your laptop home at night, you may not have a DHCP server, but you could tell Windows to use the alternate configuration so it's the same IP config every time you take your laptop home.